Alrighty, so welcome back. I trust you guys had a good break. We are currently in block 3 of the 2056 Ways to Inspire conference. My name is Eric. I hope you guys are doing well. And right now we're going to listen to speaker Tyler Holtzman on the 2056 Ways to Maximize Your On-Field Performance, segment 5. So this is Ty here, and Ty, you may take it away.
Thank you very much, Eric. Thank you, guests, for joining us. Today, we're going to be talking about 2056 ways to maximize your on-field performance. Maybe a slight exaggeration. There may not actually be 2056 ways, but there's a lot of good ways that that we've found over the years to help bring home those blue banners and help teams to achieve their goals on the field. So moving along, who am I and why are you listening to me? My name is Tyler Holtzman. I'm the lead design mentor for Team 2056. I was a student on 1114 in 2003 and 2004. I returned to mentor that team until 2007 when 2056 was founded. And I've been with 2056 ever since. In my professional career, I'm a senior design engineer for Volm companies. We specialize in material handling and automation for the food industry. And I have a brief video that kind of shows what I do more or less at work. And 2010, I won the Woody Flowers Finalist Award at the then Canadian Regional. Little video of what I do in my professional career. This is a promotional video that my company put together documenting some of the systems, but we do mostly end-of-line solutions for food processing, so case packing and palletizing. We're a systems integrator for KUKA Robotics. KUKA is a company that builds articulated robot arms like the one that you can see in this video. Now, what we do is we build the tooling, we build the conveyors, we build the solution around the articulated robot that makes it do something really cool. So yeah, you can see here's a video of a palletizing robot that's picking up boxes of I think they're nectarines or tangerines or something, and it's palletizing them for shipping. So there's we do, like I said, we do mostly end-of-line solutions, palletizing. Here's an application that's doing bin filling. Robotic bin filling is something that's quite popular these days. So this system was packing these 20-pound bags of potatoes into those large cardboard bins. I can actually see me in the background of this video. So anyways, we build the conveyors, we build the tooling, we build the grippers, we build all the stuff around the robot that makes it do something really cool. So here's just a regular old case palletizer. This is a customer in Idaho. We actually have a lot of customers in Idaho, Wisconsin, Colorado, California, that kind of area. It means that I travel a lot. Not so much now, but usually travel a fair bit for work. So yeah, this is kind of what I do in my professional career, which is very similar to what we do in FIRST, just on a larger scale and for money. So cool stuff there. Moving along, little outline of what we're going to be talking about today. First topic is going to be goal setting. So how your FRC team can set goals for success and how those goals are going to help you aim and steer your team. We're going to talk a bit about our build schedule and what no more bag or no more ship day means and how it affected our team specifically. We're going to talk a bit about how our team makes decisions about what kind of robot we're going to build. We're going to talk about functional design. So how, once we figured out what we want our robot to do, how we're going to design a robot to do that. And then we're going to finish off with some general tips that that I found can really help to improve teams along the way. So moving into goal setting. Goal setting is something that every team should be doing. And we set goals for just about everything. We set goals for the season on a whole. We set goals for an individual event. We set goals for what we want to accomplish in a specific week of build season. And we set goals for what we want to accomplish a specific day of build season. So we start very big, and we work our way down to very, very specific goals. So what do I mean by this? Some common examples of good goals that teams can set is I want to get picked for the elimination rounds. So if you're a new team, or you're maybe not a real high resource team, getting picked for the elimination rounds is a great goal for just about every team in first. Other goals may be to win my district event, or maybe you want to win an award at an event, or maybe you want to win the championship. So these are common examples of goals that teams should be looking at. But really, like, what is goal setting? So if you look this up in a dictionary, the act of selecting a target or objective you wish to achieve. Or it is the answer to, what does success look like for me? So how your team measures success is not going to be the same as how other teams measure success. For some teams, getting a robot to the field is a success. For other teams, winning a championship is a success. And every team is going to have different goals and different ways of measuring success. So some general goal setting tips. Goals should be smart. And this is a topic that I took largely from a leadership course that I took recently at work. But goals should be smart. And this is an acronym that stands for specific, measurable, attainable, relevant, and time-based. So your goals should be specific. We want to have a very good description and very clear understanding of what specifically this goal is talking about. We want to have goals that are measurable. If your goal is to be good, well, how do you measure that you are in fact good? Maybe you're rather than your goal of generally being good, your goal is I want to have an OPR that's in the top 25% of my district, or whatever that specific thing is. So we want goals to be measurable. The next thing is attainable. We want goals that are attainable for our team. If you're setting a goal that's so far beyond your reach that there's no chance that you're ever going to reach it, that's not a good goal to be picking. So if I back up to my common examples, I had win the championship as one potential goal. But the reality of that fact is, for the vast majority of teams in first, winning the championship is not an attainable goal. Not saying it's something you shouldn't strive towards, but setting that as a goal and using that as a measure of your team's success is probably not, real attainable. Goals should be relevant. Goals should be relevant to how your team feels that you want to be successful. So, I mean, if your goal is something that's completely irrelevant to FRC, then that's probably not a great goal. Setting a goal that you want to participate in the elimination rounds at your event, that's a very relevant goal for an FRC team. setting a goal that's completely irrelevant, and I can't even think of an example off the top of my head, but we just want to make sure that these goals are in fact relevant. And then the last thing here is time-based. So we want to have a time frame to accomplish these goals. Now, for us on our team, we've got a very well, documented schedule of where we want to be on each day and each week of build season. So our goals are very time-based as to what day we achieve which milestones in the build season. So this SMART acronym is a great way of choosing goals and making sure that the goals you're choosing are all of these things to be successful. So to move forward with some better examples of goals, an example goal could be a completely functional drivetrain by week 2 of build season. So here we have a goal that is specific, completely functional drivetrain. It's measurable. The thing works or it doesn't. It's attainable. Every team in first can have a working drivetrain by week 2 of build season. That's, that's just a fact. Relevant, yes, it is. That is a very relevant thing for every FRC team, is to have a working drivetrain. And time-based by week 2 of build season. It is very time-based. So here is a good example of a goal. To rank the top 8 of my district event. So you're attending the York district event or whatever district event you're attending, you want to rank specifically in the top 8. That is a very specific goal. Other example, score 3 preloaded balls in autonomous mode consistently at our first event. So that, again, that is a very specific, measurable, attainable, relevant, and time-based goal at our first event. Maybe you want to win the entrepreneurship award at your district, or you want to win the championship this season. I keep coming back to this because this win the championship, this is the primary goal that drives me and drives our team, and is something that we've been working towards for a number of years. Unfortunately, that's one of the more challenging ones to achieve. So we talked about how we should set goals for lots of things. We talked about what our goals should look like. But goal setting can kind of be a loaded question. And there's really 3 things that you have to put some thought into is, are you actually willing to do what it takes to achieve your goal? So if you have a very lofty goal, are you willing to make the sacrifices that are required to make that happen? So I talked about how our team goal is to win the championship. And that is something that takes a tremendous amount of effort from everyone that's involved in the team. So you need to know that your team is on board to make the sacrifices and put in the time that's required to do the things that you want to do. And if you're not, then you need to go back and reevaluate what those goals are. Do you even know what that is? So for a lot of teams, if you say your goal is to try to win the championship, unless you've been competing at a very high level consistently for a number of years, you don't really know what it actually takes to win the championship. So setting a goal of winning the championship without actually knowing what it takes is not a realistic goal. And is the whole team on board? And I think this is where a lot of teams can get tripped up, is where you've got a few people in the team who want to be super competitive and who want to do really great things, but they don't have the support behind them to achieve that. So when you set goals like this, you've got to know that that your whole team is on board to achieve the things that you want to achieve. And this is really important. And if you're going to measure your success based on that, you got to know that the people behind you are there to support you, and that they're going to be there when you need them to. So these are 3 questions that you need to evaluate sort of after you pick your goals. And if you can't answer these things, correctly, you need to go back and reevaluate. The goals become the rudder of your ship. If you keep changing your goals, you end up sailing in circles. And what I mean by this is, once you get your mind focused on a goal, you need to charge towards that goal ruthlessly, and not let anything, slow you down or steer you to the one side or anything like that. Once you pick your goals, you need to head down and just push towards them, and don't let anything pull you, off that track. So that's kind of goal setting in a nutshell. Well, not so much in a nutshell, but are there any questions on goal setting so far? Yes, I am legit. Yes, I am available for rental. I'll get you my rates. Any questions from the chat on goal setting? Come on, chat, you must have some questions. No questions. Okay. Well, we'll continue on. If there are questions, we can come back at the end. We'll have a general Q&A. So next thing on the agenda for tonight is our build schedule and what a typical build season looks like for us. Usually in this presentation, I do a real deep dive into what the daily and weekly milestones are of our build schedule. With the whole no build season thing, I've taken that out and gone into greater detail in other portions of my presentation. So those of you who have attended before will notice this is quite a bit more brief than the build schedule portion I've done in the past. So our typical build schedule looks generally like this. Monday, Wednesday, Friday, 2:30 to 9:30. So 3 nights through the week, and Saturdays from 9 to 6. So as a team, we meet 4 days a week. And for a lot of teams that are, competing at a very high level, for us to only meet 4 days a week might sound like not a lot, because there are a lot of teams out there that are meeting, 6 and 7 days a week. But for us, we try to meet, every second day, with the exception of Fridays and Saturdays. And we find that having that day in between the days that we're meeting gives us more time in between to get organized for the days that we're there. So we're at the school 4 days a week, and they're for significant periods of the time. Like we're there from 2:30 to 9:30, so we're like 7 hours. Back in the day, we used to meet Monday to Friday from 2:30 to 5:30. So we were only there for like 3 hours, which was more days, but we found we weren't getting a whole lot done during that time, because by 5:30, mentors weren't able to get there until it was time to pack up and leave. So switching to this schedule where we met for less days but longer days enabled us to have more productive hours at the school, and that really helped us with our productivity. So 30 official hours a week, and then outside of that time there can be as much as 20 plus additional hours of design time outside of those meetings, or getting parts ready to order, making drawings so that we have, drawings ready for the shop when we are back at the school, and that kind of thing. So that's kind of what our schedule generally looks like. Um, find a schedule that works for your team. Your mileage may vary. What I mean by this is every team has to, pardon me, every team has to come up with a schedule that works for them, works for their mentors, works for their students, that is sustainable and efficient. And not every team is going to be able to meet 4 days a week or whatever that is. So every team's got to sit down and figure this out for themselves, what works for them. And the most important thing is that it's sustainable for the team's mentors, because the team's mentors are the ones who are going to carry the team forward for the next number of years. And it can be very easy to fall into a trap where you're putting in, way too many hours to try to meet, a performance goal, and you end up being completely unsustainable. So every team's got to kind of sit down and figure out, based on, what their goals are, how much time they have available to commit to the team, about what schedule is going to work for them and be sustainable for them and allow them to meet their performance goals. No more bag. This last season, as most of you are probably aware, we had no more bag, which was a massive change. For the last, 10 years or so, at the end of build season, we used to seal our robot up in a bag with this enormous zip tie, right on some silly form that, yes, we did in fact seal it up, and then, we got a robot that's all sealed up, and we can't work on it anymore. But that was a little silly, so first got rid of it. So what did that actually mean for us? Very, very little. We did not significantly change our approach to build season, or our approach to robot design, or our approach to our schedule. We still built 2 complete robots. We did not change our approach to how we build robots. We did slightly relax the build schedule compared to previous seasons. The most notable change was prior to 2020, we would always have the mechanical design ready for release at the end of week 2. In the no bag era, we pushed that back to the end of week 3. So we allowed ourselves an extra week of design time to flush out ideas and give ourselves more time to work on the CAD before the drawings went out for fabrication. And we're going to talk about our fabrication resources a little bit later in the presentation, and what it means by the design release. Yeah, so we pushed that back by 1 week, and that was the only thing that we changed. But then all of our other weekly milestones also shifted back by that that same 1 week. But we have no plans to build a secret championship robot only, or do we? No. Last year we didn't, but the thing about the whole no bag thing is, yeah, you have more time to do a big rebuild if you need to, but I would caution the majority of teams against that. There's been a handful of teams who have successfully pulled off like major rebuilds mid-season, but it usually takes a long time to get a robot really flushed out and properly automated and working well, that most of the time, unless you really get it wrong, you're better off to just stick with what you've got and keep, tweaking and improving and iterating on what you've got rather than doing a major rebuild. Questions on build schedule. We do have a few questions from the chat. Erwin1310 asks, out of 50 hours, how much time would an individual student be putting in? So I mentioned we have 30 official hours at the school, and every student has to figure out what their own personal commitment is. We usually end up with a core group of super committed students, generally from 6 to 12 kids, who are there for all 30 of the in-school hours. And then they also help out a fair bit outside of it. So how much time would an individual student be putting in? They could be putting in from 30 to 50 hours, with 30 of them being at the school, and 20 hours outside of that would be rare. But it can happen, sometimes, leading up to the chairman's award submission, for example. They'll put in a ton of hours outside of our regular schedule to get that all done. So yeah, it can happen, but not every student's doing that. We have some students who, come 1 or 2 days a week, and that's cool. That's what their commitment level is to the team, and that works for them. But those aren't the kids who are going to be, having drive team positions or having lead roles within our team. Other questions from the chat. Is there a minimum requirement for individual time commitment? Are there opportunities for part-time members? Yeah, there's absolutely opportunities for part-time members. Generally speaking, the leadership roles, the drive team roles, the pit crew roles, the scouting lead roles are the kids who are there all the time and are committed to our team. That being said, every kid's got to figure out what their own personal commitment is and what they're able to do, because we got some kids that are in band, we have some kids that are super focused on their grades, we have some kids who are playing football or doing whatever else outside of robotics, and robotics isn't the be all end all of your high school career. So we understand that students are doing stuff outside of the team, and that's cool. And we there's lots of jobs to go around. So there's definitely stuff for students who are not able to put in, the ridiculous hours that the rest of them do. Yeah. Matt G from the chat asks, how many of your students do you think are there for all 30 hours? And what about 50? Well, like I said, the 50 hours would be rare. That's not a regular thing. It could be up to that. But we have lots of kids who are there for all 30 in school meeting hours. If I had to guess, I'd say about a dozen. And it varies from year to year, and which kids are there and what they have going on. So more questions from chat. Well, Parth from 610 had a question about goals. I'm going to loop back to that one at the end of the presentation. Don't let me forget about that. Any more questions on our build schedule? Okay. Our next topic tonight is decision making. And this is going to be how to choose the right robot to build, how to structure your decision-making process so that you're building robots that are going to meet your goals. So I have a quote up, and this quote is from Sun Tzu, The Art of War, a very famous book. I would encourage you to read it. As the quote goes, If you know your enemy and know yourself, you need not fear the result of 100 battles. If you know yourself, but not the enemy, for every victory gained, you will also suffer defeat. And if you know neither the enemy nor yourself, you will succumb in every battle. Why is this relevant to FRC? Know yourself. Prior to starting the season, you need to know your team members. You need to know what your team is capable of designing and what availability your design resources have. So, what students you have that are mechanically inclined, what design mentors you have that are mechanically inclined, and what their availability is. You need to know what your fabrication capability is and what your fabrication availability is. A lot of teams will, and I hear teams struggling about this all the time, but they design some elaborate robot and then they send it out to their sheet metal sponsor and then wait 3 weeks. And it's like, what are you doing? You can't wait for 3 weeks for this stuff to come back. You need to know that if you have a resource that is available, you need to know that it's going to be available in a timely fashion for it to be worthwhile for you. Teams need to know what their controls and programming capability are. So what I mean by that is we're not going to design a turreted shooter if we don't have anyone who's never programmed a robot before, because a turreted shooter is something that's going to require significant programming and debugging to make work well. So if you don't have those resources and those capabilities, that's not something we should be designing in the first place. You should be scaling back and designing something that's simpler and easier to control. And driver skill. Teams need to know, I mean, this is the last thing on the list for a reason, but if you're going to design a robot that's going to be incredibly difficult to drive, you better make sure that you have someone lined up who is very, very capable of driving. So, yeah, you need to know what your team is generally capable of and what its resources are before starting anything. Evaluate your abilities and resources honestly and realistically. This is really, really important to know what your team is capable of and what resources you have, and be realistic about it. Don't be like, well, we might be able to get a sheet metal sponsor, so we're going to design a sheet metal robot. No, that's not going to work. You need to know what your resources are from day one and not stretch that too much. These limits are defined by manpower, budget, experience, a number of other factors. These three are three really obvious ones. Yeah, budget's important. FRC is an expensive sport. If you don't have budget behind you, building a turreted swerve shifting shooter, probably not the best idea. Overestimating your abilities and resources is the single most harmful thing an FRC team can do to hurt their on-field performance. I can't stress this enough. It's very, very important that teams, evaluate their abilities and resources honestly and realistically and not overextend themselves. Build within your limits. This is a very famous quote from the golden rules of FRC design. Karthik gives this presentation every year. The quote goes, if a team has 30 units or general units of robot functions and functions have a maximum of 10, I'd rather have 3 functions at 10 out of 10 than 5 at 6 out of 10. This is absolutely true. The real problem is that teams think they have 30 units when they really only have 15. Overestimating your own abilities is the worst thing that your team can do, leading into a season. So instead of that 3 at 10 of 10 and 5 at 6 out of 10, you have 3 at 5 out of 10 and 5 at not very much. So going back to our quote from Sun Tzu, what is the enemy in this case? Well, the enemy is the FRC design challenge. And that challenge consists of the game challenge, the game rules, the field dimensions, the game pieces. These are all things that we need to know and understand thoroughly before we begin any decision-making process when it comes to building our machines. Slightly less relevant, but also very important, is what events your team is planning to attend. So you want to know what teams are going to be attendance and when those events are going to be taking place, because how you approach a week 1 district is going to be different than how you approach the championship, for example. So these are important things to understand prior to approaching your decision-making process. So you want to familiarize yourself with old FRC games in the preseason. So before kickoff even happens, you want to look at some old games, because a lot of game elements get recycled over the years, and there's a lot of similar things from previous year's games to the next, and there can be a lot of learnings you take from games you didn't even participate in. So becoming a student of FRC history is something that's really beneficial for new teams going forwards. Read the rules, read the rules, read the rules. I try to always read the rules, 2 or 3 times before we even start any kind of brainstorming or decision-making processes. So reading and understanding the game manual is really, really, really important. Examine ways to score points. So the last couple of games, we've had ball shooting, we've had attaching hatches to the cargo ship, putting balls in the cargo ship, hanging from the generator switch, or level 3 platform, level 3 climb, whatever it's called. You want to look at all the ways that you can score points. You want to look at all the ways that you can prevent an opponent from scoring points, because if I can deny my opponent scoring 10 points, that's just as good as me scoring 10 points, except in 2015, but 2015 was stupid, so let's not talk about that. Examine ways to prevent opponents from scoring points, because that is just as valuable as scoring points yourself. And you want to look at effort versus reward. Most games have some very low effort tasks that are worth, the majority of the points. So if we look at last year's game, for example, we had, well, I honestly don't remember what the last year's game was called. Anyways, you're hanging on the generator switch. That was the end game task. You were hanging on the generator switch with a level bar. That was the easiest way to score points, was just build a robot that just hangs. That should have been number 1 on every single FRC team's priority list, because it is the least amount of effort and the most amount of points. So you want to look at this effort versus reward for the different scoring opportunities on the field. Once we know what we're capable of and we know the game, we generally make 2 lists. We make a list of, I'm a software engineer, so we call them functional and non-functional requirements, but you can call these whatever you want. But we have things that we need the robot to do, and we have ways that we want the robot to do it. And we formed 2 lists. So number 1 on our list of functional requirements was hang. because it was the most amount of points for the least amount of effort. Then we said we wanted to acquire balls from the floor, shoot outer goals, shoot inner goals, shoot outer goals from range. That actually should have been a non-functional requirement. Manipulate the control panel and travel under the control panel. Notice the travel under the control panel was the last thing on our list. And then we had non-functional requirements. And these first three never change. Every year, the first three are exactly the same thing. Simple, robust, and effective. If we ever build a robot that is not one of these three things, well, come smack me. Fast drivetrain, high torque drivetrain, fastball pickup, hold 5 balls, never jam. Jamming was like kind of terrible last year. And there were a lot of teams that were like amazingly good for 20 seconds and then they would fatally jam and then drive around in circles trying to unjam themselves for the next who knows how long. So never jam was something that was really important to us. We wanted to shoot 5 balls in less than 2 seconds, and we wanted to have a robot that was easy to operate. Easy to operate should be on everyone's list. All robots should be easy to drive. If the robot is hard to drive, chances are that you will make a mistake at some point. So being easy to drive is really important. What have I got the logo in there twice? I do. Next step of decision making is to take those two lists and merge them into one, respecting what your team's goals are and what your capabilities are. You want to, at this point, identify any trade-offs. If some years, for example, doing activity X precludes doing activity Y, so you can't do these two things at the same time. 2013 is the best example I can think of that. We had two largely mutually exclusive tasks of picking frisbees up off the floor and shooting them during the autonomous period, and climbing to the top of the pyramid during the end game and scoring these frisbees at the top of the pyramid. These two tasks were both extremely difficult, and it was very, very difficult to package a robot together to do both of those things concurrently. So most teams had to choose one or the other. And that was a discussion that we had. Ultimately, we decided that we wanted to go the route of the floor pickup because the first tiebreaker in qualifying was auto points that year. So that's what led us down that way. General side note, our team typically prioritizes the qualification seeding points because we want to be able to rank very high in the seeding and control our own destiny for the elimination rounds. There's a few examples of robots over the years who have been phenomenal elimination robots, but weren't particularly good at controlling their own destiny. Yeah, there's two sides to that coin. So teams got to, examine those trade-offs and figure out which one makes sense for them. So at this time, you can, once you identify those trade-offs, you can decide on drivetrain functionalities, and this list will really drive the functional design for the rest of the season. So at this point, you're figuring out, generally what you want the robot to do. Maybe not exactly how to do it, but you know what you want your robot to do. A little bit about decision making, consensus versus voting. On our team, we make decisions based on consensus, not by voting. And the reason behind that is, should a grade 9 first year on the team, should his vote count for the same as 4 or 5 year alumni who's maybe has a degree in engineering now? Probably not. So whenever we're making a decision or we're really stuck on a decision, we talk them out, we hash them out, we weigh the pros and the cons, and then we come to a consensus among the group. But we do not vote on design decisions. Know your limits, design within them. I can't stress this enough. Don't do everything. Almost always, it is a bad idea to do everything. There are very few games where doing everything is possible or wise. And even for the highest resource, highest performing teams, doing absolutely everything possible is generally not a good idea. And even on our team, we generally try to pick a few things, few trade-offs that we can not do to simplify the rest of the design challenge. So this past season, the ability to go underneath the control panel was something that a lot of teams thought was very important, and we didn't. And by not doing that, it made hanging easier, it made shooting easier and more consistent. It made not jamming easier and more consistent. It made a lot of the rest of the design challenge much simpler. And we're still happy with our decision not to go underneath the low bar. And I don't think that, well, who knows what next year is going to look like, but doing it over again, I still wouldn't go underneath the low bar. So doing everything, generally not a good idea. 2019, for example, we did not try to lift partners with us when we climbed to level 3. It's something that we talked about, but eventually ruled it out for simplicity's sake, and we felt that trying to do it would compromise the design of the rest of the machine, taking too much weight and resources away from the rest of the scoring to be really worthwhile. So don't do everything. Any questions on decision-making process from the chat? Come on, chat, you gotta have questions. Usually this is a very interactive session. Can you explain, question from Parth, 610, can you explain why in 2016, then why you thought to do everything and what was the trade-off there? 2016, we didn't do everything. We completely ignored the Sally port and the drawbridge. We said we're not gonna touch those defenses. Other things in 2016 that we considered doing was building a type of articulated shooter so that we could shoot from high rather than shooting from low as we did. Other things, trade-offs that we made in 2016 to simplify the design was not having a turreted shooter. We had a fixed shooter and we had to turn the whole robot to shoot. So there were quite a few things that we specifically didn't do in 2016 that we could have done that we didn't to simplify the design. And it's more than just achieving game challenges. It can be, ways of achieving game challenges. So, I mean, we saw, for example, in 2016, 1241 had a high turreted shooter, and the robot was incredibly accurate up close to the goal. And really the only thing that they couldn't do was go under the low bar. But there were so many other low robots in 2016 that going underneath the low bar, you almost always had a partner who could do it anyway, so it really wasn't a requirement. So 2016, that 1241 robot was a great example of not doing everything and being really good at it, because them being tall made them a much more consistent shooter up close. So yeah, I think that answers your question. But yeah, the trade-off there was there were other things non-game challenge that we didn't do to simplify design. Matt G 4039 asks, you said preventing an opponent from scoring points is worth as much as scoring those points yourself. how good would a defense bot have to be the first overall pick at an event? And do you think it's feasible for a team that wants to compete at the highest levels to build a defense-oriented robot? This is an amazing question. So how good would a defense robot have to be the first overall pick at the event? Depends on the depth of the event and the composition of teams at the event. Funny story. So last year at IRI, we had a bit of a debate. It was short, but we had a bit of a debate about picking a defense robot first overall, because there was one defense robot in the field who was very, very good at it, but there were a whole lot of scoring robots in the field. And this one particular defense robot was like head and shoulders above the rest of them, or at least gave us the impression that they were head and shoulders above the rest of them. So we strongly considered picking a defense robot first overall at IRI last year, rather than picking a scorer. In the end, we didn't do it because we wanted to, pick 11-14, because who doesn't want to pick 11-14? But anyways, is it possible? Yes. Do I think it's feasible for our team that wants to compete at the highest levels to build a defense-oriented robot? No, I don't. Good D-bots are hard to come by, and they're incredibly valuable, but you can't build an alliance around defense. Our team has a very good track record of choosing very good defense robots. 2016 championship run was based largely around defense, and our best matches came when our defender was really on it. And I don't think we would have made it as far as we would have on scoring merit alone had we not been playing defense. 2016, specifically on Einstein Field, most of the other alliances were not employing a defense robot. So to answer your question, do I think it's feasible for a team to compete at the highest levels to build a purely defense robot-oriented robot? It would depend on the game, the last number of games. The answer is no. But they would have to be pretty good at defense, like the ability that they could stop any other robot from scoring any points. And you can get situations where a team can play defense plus also do end game, and that can be very, very beneficial. If you go way back to 2003, 2004, you saw examples of games where teams would literally just demolish the other alliance for a minute and a half and then go hang. And the points that they would score in the hanging were more than what the other alliances scored in the entire rest of the match. So it depends a bit on the game, and the last couple of games, the answer there is generally no. Question from Parth 610. When you are deciding what is too much for 2056, what do you consider? How much do you consider that based on the students versus the mentors' abilities and experiences and desires? That's a good question. We've had a very solid and stable mentor base for the last number of years. So having that not change and having that have been stable has been really good for us. So most of the kids come in and they're gung-ho and they want to compete at a high level. So that part of it has been fairly consistent from the last couple of years. And the abilities and experiences of the student base is generally fairly consistent from year to year. Every so often you get a rock star who's, well, a rock star, and they're a really capable, really gung-ho student who's capable of a lot. But to answer your question, it doesn't really change too much from year to year, but it would be mostly based on our mentor base's capabilities and experiences. I'm going to come back to the question about the goal setting at the end of the presentation. So yeah, again, to summarize, the question was, how much do you consider experience of the students versus experience of the mentors when deciding what is too much for us? And it's mostly based on mentor experience. Any more questions on decision making? Okay. Next topic and final topic is on functional design. So now that we've figured out what we want our robot to build, we're going to figure out how we're going to build it. So the first thing that every single 2056 robot is going to be is simple, simple, simple. That's the number one thing that that we want our robot to be. And when you look at one of our robots from 20 feet away, they may not look simple, but when you actually break it down to the functions of the machine, they generally are simple. We want our robots to be robust. One of our goals is to have 0 mechanical failures throughout the season. We want to never ever break, because one of our goals is to be seating high, and to seat high, you need to perform consistently. And to perform consistently, you have to never break. So we want to be a very robust robot, even if it means doing less things. We want to be robust to the point that we never ever break down. Going along with the simple, when we have fewer parts, we have less things to design, we have less things to fabricate, and we have less things to fail. Avoid doing everything. I keep coming back to this. Avoid doing everything. It's very important to not exceed your resources. So at this point, we look at different robot architectures. So we do some whiteboard sketches of what different possible robots could look like, and identify the trade-offs of each. So last year we have the example of the tall robot versus the short robot. Some trade-offs of the short robot is, yeah, you can drive underneath the control panel. So you have that avenue to get up and down field. But your trade-off is you're going to have worse shot trajectory. You're going to have a less consistent shot. You're going to have a fewer percentage of inner shots. So there's some trade-offs there. At this point, we prototype as necessary. We are not a prototype heavy team. We actually build very few prototypes. But if there is a specific function that we're trying to see if we can use tiny mecanum wheels to direct the balls into our intake, we'll build a really, really janky prototype with a cordless drill and some hex shaft, and we'll stick a bumper on the ground, and we'll try that out. And we'll prototype, things or functionalities that we're trying to figure out, maybe a specific geometry of how to roll a ball up over your bumper and get it to land into your robot, like the position of the rollers that you need to do that. But yeah, these prototypes are very, very terrible. And they have just enough effort put into them to prove or disprove what we're trying to achieve. So at this point, you want to decide on a direction, respecting your goals and capabilities. So for us, it was, yes, we're going to build the tall robot. And again, I just have reinforcing design according to your resources. So our resources, I'm going to talk a little bit about what our resources have and how that drives our design process. So at Orchard Park, we're very, very fortunate to have an extensive machine shop. We have a lot of space, which is something that's often overlooked. But we've got a full machine shop with CNC vertical milling machine, a couple of manual vertical mills, 6 manual vertical lathes, horizontal vertical bandsaw. We have a box and pan brake for simple sheet metal bending. We have a full wood shop, 3D printing. So we do a lot of fabrication, as much fabrication as we can at the school. And that's what we're doing during our 30 or so hours during the week at there. Now, our outside fabrication resources, we have 2 primary outside fabrication resources. The first one is Westbrook Greenhouse Systems. They're a company that builds greenhouses, actually. But they have a tube laser. It's basically a laser cutter that can cut on all 4 faces of a piece of tubing, and you can basically have a full, complete part pop out finished in a single setup. So we can make really elaborate aluminum tube parts in a single setup in much, much less time than you could machining these things conventionally. So the photo that's shown here is was the lower stage of our climber last year. It was a piece of 2x2 tubing, and a part like this will take about 4 or 5 minutes to cut out on the laser, and it'll cut 5 of them in 20 minutes. So we're able to get the fabrication done much, much faster than we could if we were machining that traditionally in 4 setups on a router or a CNC mill. And yeah, the part just pops out done. The laser does leave a fair bit of slag on the inside of the parts, so there's a lot of manual cleanup to do after the fact, but it's still way faster than machining them traditionally on a milling machine. And we wouldn't have the capacity to do it on our mill anyways. Our mill is quite small, so a part like this we would have to do in 8 setups rather than 4 setups. And yeah, we just don't have the time to run something like that. So the other outside fabrication sponsor we have is Barlow Manufacturing. They're a engineering company here in Stony Creek, and they have sheet metal capabilities for us. So they can cut out. They have a 6,000 watt automatic sheet metal laser that we cut out a lot of fabricated sheet metal components on. So the majority of our chassis, a lot of large sheet metal components that's too big for us to do at the school, they'll cut out for us. So they take a 4x8 or a 5x10 foot sheet of aluminum, load it into the machine, and cut out 100 parts at once, and they'll cut out all the flat parts. And then they can take them for bending after the fact. So there's a little sample video here of a machine cutting out 3mm aluminum. We get 1/8 aluminum in Canada. The video just shows 3mm. And they also have CNC brake presses that we can bend the flat components to whatever shape that we need. So a couple examples from our 2020 machine is the ball hopper here was this fairly elaborate bent sheet metal structure, and the drive chassis is also shown there. There's a number of sheet metal components that are all bent to fit together. Yeah, the CNC brake press is pretty slick. The backstops on the brake automatically adjust for the different bending operations, so you can bend quite elaborate shapes very quickly. Buy everything you can, make only what you can't and are capable of. So I say this because the one resource that every FRC team has the same amount of is time, and none of us have enough of it. So we buy everything that we can because Well, it saves us time. We generally don't make gearboxes anymore. We usually just buy off the shelf gearboxes and use them wherever it makes sense. Um, make only what you can and are capable of. I see teams constantly trying to fabricate things that they don't have the capabilities of doing. And a lot of that comes down to inexperience, but knowing what you're capable of making is really important so that you don't waste time trying to make something that you're not capable of. Order parts early, finish early, and iterate. The FRC ecosystem is fairly limited in the number of vendors we have to buy stuff from. You've got Vex Pro, you've got AndyMark, you've got Rev, ThriftyBot, West Coast Products. We have a handful of vendors who um, have limited stock. So when you know you need something, order it right away, because there's a chance that those limelights are going to go out of stock, or there's a chance that the ball shifters are going to go out of stock, or 4-inch mechanical wheels, or whatever that hot item is of that given season. Order early. Last year, for example, we ordered our wheels and drivetrain on the Sunday after kickoff, like literally a day later. 2012, 8-inch pneumatic wheels went out of stock on Tuesday of week one. At that point, we had already ordered 20. And a lot of teams were really hosed because they couldn't get the wheels to finish the robot until week 5. And at that point, it's like it's too late to be putting your drivetrain together. You're already, way behind the 8 ball. So order your parts early to make sure that you get them. Stock is limited in FRC. Yeah, it never hurts to get ahead here. CAD everything or not. Remember your resources. We're a very heavily CAD driven team. We CAD everything before it gets fabricated. And that's because we're a team with a lot of CAD horsepower. I myself do SolidWorks design basically for a living. So we have a lot of CAD horsepower to really flesh out designs very well in SolidWorks prior to fabricating anything. That being said, if you're not a team that has a lot of CAD horsepower, maybe you want to focus your design efforts on your gripper or your manipulator or your a specific geometry of your ball intake, or whatever is going to be the most value for you, rather than trying to design an entire robot in SolidWorks, but having that take so long that by the time you get around to fabricating it, you're already way behind. Like SolidWorks and Inventor and Onshape and whatever CAD package you're using is only valuable if you have the engineering throughput to use it in a time efficient manner. If it becomes this massive exercise in design and ends up being more of a burden to you, then you're better off to do some hand sketches and paper sketches and whiteboard sketches and figure out your important geometry that way, and then just start building the thing. Like you don't need to fully design in CAD every nut and bolt to start fabricating, especially if that's going to be a bottleneck for your team. So yeah, remember your resources. Remember what design experience your team has, and then make your processes based onto that. Look to the past for inspiration. Whenever I design a robot, I look at the challenges that it has to do, and then the first thing I ask myself is, has anybody done this before? Like, there are thousands of ball pickups examples in FRC in the last 20 years, literally thousands. Ball grabbers, tube grabbers, arms, elevators, turrets, swerve drives, tank drives, you name it, somebody's done it before. Generally speaking, if you don't need to reinvent the wheel, don't. So we always look to the past for inspiration. This slide shows our 2020 robot beside our 2012 robot. I'm sure you will notice there is a lot of design similarity between the two of them. And we did have the lessons learned from that machine, and there were some things that we did differently. And 8 years in the future, FRC has changed a lot since 2012, but there are a lot of design similarities between these two machines and lessons learned from those previous machines. So, and you can look outside your own team. Like I'm not just talking about looking at the robots that your team has previously built. Look at the robots that other teams have built. Yeah, being a student of FRC history is really, really valuable um, to come up with some really good design ideas. Questions on design, chat. Question from RJ Coach 3538. Have you regretted any design decisions? Yeah, absolutely. Like who hasn't? Uh, the biggest one is probably 2008. 2008, there was this enormous ball that you had to lift over top of the overpass. And fairly early on, we kind of ruled out launching the ball or really didn't give it much of a thought because this ball was enormous. So we built an arm that lifted the ball up and placed it over the thing, and then we drove underneath and chased and picked it up. And then at the end of build season, we saw all these videos of people just like chucking the ball over top of the thing, and we were kind of just like, shoot, why didn't we do that? So yeah, like there's always stuff that you regret. Recently, I regret not putting more emphasis on climbing with a partner in 2019. We had a robot architecture that climbed solo itself very easily, but it didn't leave enough room for a partner to climb with us or for us to climb when a partner had already climbed. So that was a big one. We ruled out the whole suction climb thing fairly early, and that was based on some bad janky prototyping. So we should have put some more thought and design effort into that. But we didn't. So yeah, I kind of regret that. That's the biggest one in recent memory. Other question, do you regret any goal setting decisions? No. No, I can't think of an instance where I would regret setting a goal. We've always been careful not to set goals that exceed our capabilities. So I can see where that could be an issue, but if you stand by the SMART goal setting, then you should be successful and not regret your goals. Any more questions on functional design? Come on, chat. No questions? Okay. Last section, some general tips. Finish early, iterate. Like I said before, we're not a team that prototypes a lot. We generally choose a direction very quickly and then go. We tend to have our practice robots done very early. I didn't do it in this topic, but in most years, in most pre-bag years, we've had a practice robot functional by the middle of week 3, like done, wired, and running, not fully automated, but at least wired and running. And then we have, all that time to automate, to iterate, to make design changes on a finished robot. We generally don't spend, a whole lot of time up front coming up with a concept before diving into design and manufacturing. So we're big on finishing early and then iterating on that design. Practice, practice, practice. Practice is so important. Our drivers practice a lot. They practice at lunch, they practice after school, they practice every day. And we make it very, very easy for them to practice. Usually when I give this presentation, I'm standing in the middle of our practice field. Um, obviously, I'm not right now, but we have a practice field at the school. It's about 2/3 size. And our drive team just goes and eats lunch at the practice field and they drive the robot. Same with after school. They go for half an hour after school every day, and they practice. And we make it very easy for them to practice so that it's not a huge burden on them personally, and they can be really efficient about their time. Um, so yeah, we practice an awful lot. Don't neglect the programmers. Um, so often I talk to programming students at events, and there'll be a kid sitting on the practice field with their robot, and he's looking dejected because he can't get, this autonomous that he's trying to get working. And it's literally the first time that he's had any opportunity to work on that robot, and it's at the practice field at the event that they're attending. Um, and you can't help but feel for them because like you've got this impossible task because they've been given zero time to actually work on the thing. But the autonomous portion of the game is really important. Usually points are doubled or there's more opportunity to score points during the autonomous portion. So it's really important that you give the programmers the time that they need to develop consistent and high scoring autonomous modes. We're also a team that's really big on automating significant portions of the robot control to make it easier for the drivers to drive. We want to automate things that help the drivers, not the other way around. So last year, for example, we had smart positions for our elevator height that would automatically raise and position the hatch grabber at the correct height for the different levels on the rocket. And that was just a simple button press rather than, manually pushing up on the joystick until the elevator got to about the right height based on the guy eyeballing it from 30 feet away. We had smart positions and feedback for that kind of thing. We also had an automatic driving sequence that would automatically drive the robot right into exactly the right point to eject the hatch onto the rocket based on the position of the vision tape there. And when you're like 30 feet away and the robot's 90 degrees to you and you're trying to line it up with the cargo ship, that's a really difficult thing to do by eye. So if you can automate portions of that on the controller, you can really improve your performance. But that all takes time that you have to give to your programmers to do. And teams really got to figure out what the best use of their time is, whether it's practice or programming. And early in the season, it leans more towards programming, and later in the season, it leads more towards practice once the programming's kind of at a bit of a plateau. So really important not to neglect the programmers. Quick thanks and shout out to our sponsors, Innovation First International, Barlow Manufacturing, CNC Woodcraft, our longest standing sponsor, been with us every year since 2007. Westbrook Greenhouse Systems, General Motors of Canada, International Springs, the Winona Men's Club, Orchard Park Secondary School, and ArcelorMittal Dofasco. Final questions from the chat. I see we got a couple here. Is one reason you simplify your design so that you can spend more time optimizing what you do design? Yes, absolutely. Yeah, the answer is pretty much yes. We absolutely simplify the design so that we have more time on the back end to write programming, to write auto modes, and to automate more of the system and really optimize the design. It's rare that you build a mechanism and get it absolutely perfect the first time. So, I mean, it's nice to have extra time on the back end. I mean, I say that we're not a team that does a lot of prototyping, but we just prototype a finished robot. That's what we do. And then we iterate on that finished robot instead of, spending a bunch of time building a kind of crappy robot that's, a wooden mock-up or whatever, and then iterating that and then building the final thing and then still iterating that anyways. We just get straight to the more or less final product and then iterate it. If that answers your question. Irwin1310 asks, has the lack of bag helped the programmers since there are two bots to work with? Yes, definitely. They no longer have to fight the drive team for, access to the robot during practice time. Yeah, we literally had two robots running for a while. So we were doing programming and auto modes on one while, drivers were driving the other one. And that was great. We never made it to the field this year, which was kind of crappy, but it was really nice to have both of them out of the bag. It was weird. It felt strange, but it was good at the same time. We kept the runtime on the competition robot to a minimum, so we drove it enough to know that it didn't have any loose bolts, and we shook it down well. We knew that weren't any wires that were loose or anything like that. But it was 1/10 the runtime that there was on the practice robot that was actually starting to have some wear and tear on it by the time everything fell apart. So yeah, lack of bag definitely helped programmers. What teams need to be careful of is that they don't fall into a trap where they think they have all this extra time because there's no more bag, and then still not have any time for their programmers. Like I attended Humber in week 2, and the automos there were no better than they were at an event last year. So I think a lot of teams got into that trap where the no bag thing just let their schedule slide, and then they still gave the programmers no time to do anything. So programmers, I feel for you, I really do. And I'm fighting to give you more time with your robots. More questions? I need to come back to Parth's question from before on something. How do you know when a goal is too steep? This is a difficult question. Parth from 610 asks, how do you know when a goal is too steep? Well, you need to look at that goal in relation to other things that you have previously achieved. And if it's an incremental increase over what you've previously achieved, then that's probably a realistic goal. If it's like night and day different, maybe you want to, have a stepping stone that's closer to what that goal is, rather than just diving it head first. So, yeah, I mean, it takes a degree of experience to know whether or not you know what you're talking about, if that makes sense. But yeah, you want to try to choose goals that are, a little bit beyond what you have previously achieved, enough that, it's a stretch. Like a stretch goal is a good thing to have. That's, it's within your grasp, but you really got to work for it. But still realistic in that it's not like grossly out of reach. Matt 4039 asks, I like FRC, but I don't like cars very much. Why should I watch Formula One? Isn't it cars just driving in circles? No, these tracks are not circles. If you want to watch cars drive in circles, go watch IndyCar. If you want to watch something entertaining, please watch Formula One. More questions from the chat, please. On any topic that we've talked about, or even if you have general questions for our team, we'd be happy to answer them now. Come on, chat. There's got to be more. Boo. Okay, then if there's no more questions, I think we'll wrap this up for today. Thank you very much, guys. As always, if you have questions, feel free to reach out to us on our social media. Good luck, adieu, and we hope to see you next season.
Alrighty, so that seems to be it for today. So I hope you guys enjoyed Ty's presentation. Thank you very much to Ty for presenting. I hope you guys all found that useful. And thank you for attending today.